Recording. So, good afternoon. I apologize for all this change and all that. I was playing soccer. I was playing football there on the last weekend, and being being a little older than my knees giving me a bit of trouble there today, and I was hobbling around there last night, and I was thinking, no, you know what? Might as well make technology work for me. So we're doing all this, and we can you can see me without a mask on. Woo! I do have a mouth. There you go. So I hope you guys are doing all right. The I've updated the PowerPoint. I sent the new announcement out, and sorry, I do this for all my classes. I post the PowerPoint, and then I always update it and clean it all up. I do that every year, and I clean things up. So hopefully, there you guys have you'll see the new PowerPoint there because we're going to do it right now. Um, Excuse me. You guys have the link here from my WebEx, and if this ever happens again, we'll do the same thing again. I did update the syllabus because this chapter here deals with a little bit of chapter 21, which is the peripheral nervous system. So I've updated the syllabus there. There's a couple things there. We're not going to go too crazy into, it's kind of general overviews of all this kind of stuff. So nothing too crazy. And next week is your test. So there will be no class, all right? And what will happen is the next week's test will open at 12 o'clock there next Thursday. It'll be on Blackboard, so you don't have to come to class, okay? And I'll give you more details there this weekend about it, but it will be online. I was kind of hoping there to have it in class, but you know what? We'll start this out. We'll start it out online, and maybe for test 2, I'll bring you guys in there for class for the test 2. But for this one here, we'll just keep it easy peasy, and that's what it'll do. You'll at least have the 3 hours there. I might give you some more time, a little bit of flexibility there, because I know some people will be at school and maybe they'll have to go home to their laptop or whatever. So there'll be a little bit more time and that kind of thing. The test will comprise multiple choice. There might be some matching, and there will be some diagrams. All right, but you'll have lots of time to complete it. Any type of VR test, the don't have your resources in front of you. Have your PowerPoints ready to go. Have everything there that you might need to recall. Okay. Even have a friend around, call your nearest neurosurgeon to help you out. That would be great. If you know a neurosurgeon, that would be a good one. But honestly, you could do these tests in, you found that funny, eh? Yeah. But honestly, these online tests, it might sound weird, but honestly, have somebody with you. Somebody in your class. Bounce things off your classmates, and do these kinds of things, because social learning, what we call in the profession collaborative learning. You know what? I love it. That's how society works. If you go and get a job at IBM or some biotech firm or wherever, you're never truly by yourself in a company organization. You're in teams because people think differently, and psychologically, it's better for the end product. Now, if you're working in a company, the end product is whatever you're selling. In a testing situation like this, the end product is going to be your mark. And I hope you guys do that now anyways with your assignments, your lab assignments, all these kinds of things. Okay? I hope that you bounce ideas off. I know some of you guys have been bouncing ideas off me. Great. Don't bounce ideas off me there the day the lab is due. If you have questions about the lab, let me know there before and we can work something out. But bounce ideas off of each other. Okay? Like maybe Hi guys, if you're just joining us, you haven't missed anything. I'm recording this and I'm just rambling. So oh man, why is that so loud out there? All right, but so just a little recap. The syllabus is updated there to include a little bit of chapter 21, which is the peripheral nervous system, which this lab or this lecture encompasses anyway. It just didn't reflect it there on the syllabus. I hope your labs are going well. If there's any issues with the labs, let me know. Okay, I haven't heard too much, and I hope that they're all doing well. The PowerPoint has been updated. Okay, and the next week's test, there is no class. We'll do it online. You know, online has its perks. Like there today, I got a bad knee. Rock and roll. We'll do it like this. Okay. Which I will. I'm recording this as we speak, so I'll post it there to YouTube or to some other format that y'all can get it to afterwards if you're unable to watch this at the time. But your test there next week will be VR. It'll be on Blackboard, so you don't have to come to class. All right. I'll post this announcement as well too. Okay, and I'll give you guys more details because I'm still working on the test there. It'll be multiple choice and 1 or 2 diagrams. Nothing too crazy, but you know, it is what it is. Okay. Other than that, I think we are doing all right. Do you guys have any questions for me?
Hello, sir. I have sent you email about my question.
Okay, if you sent me an email, that's all right. Do you feel like talking about your question now, or do you? If it's of a private nature, I'll reply in the email. It's up to you.
No, no, it's fine, sir.
Okay, if you wanna, what is your question?
My question was that last time you told us that heart muscles, or we can say cardiac muscles, they respond to each other and they communicate to each other by electric medium. But there are some examples like parasympathetic and sympathetic nervous system, which is controlled by hormones like noradrenaline and adrenaline. So how is this scenario?
Okay, well, I'll have to reply to that through an email. So that's from a different lecture there, and I'll get back to you on that one there. I don't know what was the audio. I couldn't. I heard heart muscle. So hold off on that. I will. I'll reply there to the email because I think you just sent it because I checked my emails there about half an hour ago and I didn't see any. But I will get that back to you. Very good. Are there anything else there about the curriculum or anything else? No? Okay. I don't know what that sound is, man, but it just means I gotta close my window and it's gonna get hot in here now. Okay, so what is going to happen here is this lecture here is a good one. Okay, and thank you guys for coming. I'm just going to pull up my PowerPoint here. Yeah, this one here, we're dealing with the central nervous system and the peripheral nervous system. And it's heavy. So, hopefully here, what is that sound? Oh, there's some machine doing stuff out there. Okay, good enough. Great. Just as I'm doing lecture, we have some machine outside. Okay, so what I'm going to do is we are going, there we go. And hopefully there you guys can see all this there. And I'm just going to push this over here like this. We've got, this is going to be a good one here. And I guess every 50 minutes or so, we'll take a little bit of a break. And what I'll do is I'll stop recording and we'll take 10-minute break. And then we'll come back and we'll do another 50 minutes and we'll take another 10-minute break and we'll come back until we're done. So this is the way it'll be. And if you guys have any questions, just speak out because if you write any comments there, I won't be able to see them. I'll see them at break time. If you guys have any personal or questions there you do not want to share with the group, which is totally fine. It's all good. Shoot me an email and I'll get back to you guys there. Hope that sounds okay. I hope you guys are doing all right. I'm looking forward there to your next test, your first test there in this course. It's a good one, and I don't want you guys to be too freaked out about this test. Like, you look at what we've covered in week 1, week 2, week 3, and this will be week 4 here. The amount of information is astronomical. And this is one of the reasons why I'm not a big fan of tests. Because, number one, what if you had a bad night? What if your son was had a flu, and you were up all night, with your son taking care of your kids? How are you going to do on the test tomorrow? You're not going to do great, right? So the tests, because there's so much information, and what I'm going to test you on 60 questions. Well, in theory, to cover all the information, I should be testing you guys on about 400 questions, but it's impossible. So the test I'm going to give you is truly not a representative of the information there that I'm presenting to you, but there will be some specific tidbits of, I'm going to ask you, but generally it's all about generalized knowledge of what we've talked about, okay? And I really don't have the time to go into the specificities of, your cerebrum. I could write 1,000 PhD thesis on the cerebrum. You know what I mean? And I think that's one slide. No, I think that's 3 slides in my PowerPoint. So you know what I mean? The attention to detail is lacking, but we're covering all of these things there in some capacity. So I hope you guys are doing all right. Please ask questions. I thank you to those students who are asking questions and who are emailing me. And, I love it. I really, really do, because that shows me there that you're hungry for knowledge, you're hungry for learning, and I love it. So keep at it, keep asking questions, okay? That's where we're at. If you downloaded the PowerPoint there I put there yesterday, I've updated it, and I've actually cleaned it up significantly. I think the PowerPoint there that I originally posted was like 75 slides, and you'll see here that this one here is 52. I've cleaned it up and consolidated it, and it's what I do every year. I get new textbooks, I get new information, I get new stuff from the publishers and updated it. You know what I mean? Everything has to be updated to some degree, okay? And all right, ready to go? Good. All right, just to recap, as with the heart and as with the muscle and the bone, and they all have these coverings. All right, they all have these layers, right? And I just wanted to quickly show you guys that on the outside of a spinal nerve. Oh my gosh, man, that is so loud. What are those guys doing? On the outside of a spinal nerve there, we have the epineurium. Okay, what we have here now is he's got these fascicles. And just like muscle, you'll remember, if you haven't taken muscle, you will there next semester in 1032, and you'll actually see the same thing. That muscle kind of looks the same. It's completely different, but in the fact there that it has these fascicles within there. And then instead of muscle fibers coming out, okay, all right, out of here, all right, it's kind of there's the same thing here. So we have the covering there for the spinal nerve, epineurium. We have the covering there for the fascicle, which is the perineurium, okay? And then the neurons themselves, you have the covering there, the endoneurium. And you could see how there would be a multiple choice question, at least one of these guys here. You'll remember there the myelin sheaths. Remember the Schwann cells? Holy, now we've got a police chase going on. Where am I? Crazy, man. This is Barrie. Everyone's, it's 12 o'clock here, and there's so much noise, I can't believe it. So I just wanted to put these ones in here just to let you guys know. Okay, there might be a question on there. You'll see there that these neurons, there's blood vessels. They're alive, they're growing. That's what we're talking about there. I've shown this to you guys there before, divisions there of the nervous system. You'll see there that there's the CNS, which is the central nervous system, which composes the brain and the spinal cord. Okay, that's kind of your axis. And then laterally, okay, you have the PNS, which is the peripheral nervous system, and involved in the cranial nerves. Okay, so you can move your face, right? You also have your spinal nerves, which means there that you can move your hands and your legs and all these kinds of things here. Okay. We'll get more into, today is going to be kind of heavy. It's good stuff though. All right. But I think for some of you guys, it might be a little bit of review. So we'll see how it all goes. And just to recap there, the neuron is the basic cell. Getting right into it. Welcome to the brain. Now, am I a neurosurgeon? No. All right. But I've taught this there many times, and the brain, it's fun. There's so much to it, and yet there's so much we don't know. And little bit by little bit there, I hope you guys go on and make amazing brain discoveries, change the world. The brain weighs over about 3 pounds. Okay, it's about the size of 2 fists, give or take. Not that big. Pinkish gray tissue and very wrinkly. All right. And I put in here there that it kind of looks like cold oatmeal. Not the greatest thing. There is a lot to it, even as far as its own security goes. Like the whole idea there that when we bring, like here in Canada there, it's a cold country. So in the wintertime, we do not grow our own tomatoes. All right. They come from Brazil or Venezuela or wherever. They come from down in the States. And when we get these trays of tomatoes, you're probably thinking, okay, we're onto the brain. Why is this guy talking about tomatoes? There is a point. When you bring these tomatoes in from another country, they come into a box. And tomatoes, I use that example because they're kind of squishy and they're kind of soft, right? They're not like an orange or, an apple that's kind of hard, So these tomatoes, they're kind of soft and they're delicate. And when you bring these tomatoes over from far away, they come in a box. And these tomatoes have been sitting on this box, right? They've been sitting on these box and they've been rumbling and moving and shaking and, and all this. What happens to the bottom of the tomato when some of them there? It gets bruised, right? And you don't eat that part of the tomato because it's been bruised because it's been banging on the box since Venezuela. Well, your brain, think of it as a tomato. Think of it as a tomato. You're shaking your head around. Your brain is actually sitting. If your brain was just sitting on the base of your skull, it would end up like a bruised tomato, which ain't good for anyone's brain. All right? So the whole idea there that an elephant or a rhino goes into the water, why do hippos go into the water? For buoyancy, right? And your brain sits on CSF, cerebral spinal fluid there, to give it some buoyancy. There's all these different things which we're going to talk about. We're going to talk about meninges. Okay? These are the linings of the brain. We're going to talk about the blood-brain barrier. Okay? All these different protective measures there that over millions of years of evolution, the body has devised to safeguard the brain. Because as far as I know, everybody in the history of humanity dies from brain death. And technically, once the brain dies, that is death. No matter how you die, we all die from brain death. So when the brain is gone, that's it. But we'll get more into this here. Protection includes the skull and the vertebra. Okay, the vertebrae there. Okay, which we'll get into the spine, designed to protect the spine. Okay, the spinal cord. And if you look at which we'll get into, the spinal column itself, just look how amazing it is. It's all individual pieces that can move on their own. And it's such a delicate piece of equipment. And but we'll get there. We'll get there. The skull, okay, and the membranes there are called the meninges, okay, which can fall prey to diseases like meningitis. We'll get there. Primary source of energy for the brain, glucose. There's your blood-brain barrier, and the... Is my dog okay? You okay, Harley? You gonna make it there? Beagles. Yeah, they're right up there with pugs. The whole idea of the blood-brain barrier is blood is good. We all need our blood. I like my blood. It helps me breathe. It delivers oxygen there to my big toe. And you know what I mean? Blood is great. My circular system. Oh, poor dog. Got some asthma or something. But the whole idea there that the circulatory system does what it is, and it's a great thing. But also blood can be a vector for pathogens as well. You know, our whole immune system, we have lymphocytes, phagocytes, and macrophages, all these that are designed to, I call them sniffer dogs, to sniff around for bacteria, fungi, viruses, destroy them, right? But the point is that these bacteria, fungi, protozoa, viruses can get into the circulatory system. Harley, relax. If it's not the machines outside, it's the dog in the next room. What are you going to do? But the whole idea there that the blood can be infected. Okay? And, okay, your body initiates protocol to disinfect, to clean the blood, raising temperature, inflammation, mast cells, whatever, But by the time these protocols are initiated by the body, the brain could already be infected. And that's why there is this blood-brain barrier. Okay? It's just an added protective measure to protect the brain from anything there that might potentially pose a hazard to it. The neurons are kept separate from blood-borne substances. Metabolic waste like urea, toxins, proteins are prevented from entering the brain. Proteins, especially, I'm sure if you guys have heard of prions, Prion. Mad cow disease exhibited in humans is called Jacobs-Creutzfeldt disease. Okay, prions are just proteins. There's not even any genetic material associated there with these ones here. So there's lots of bad stuff out there. So that's why we have this blood-brain barrier. Nutrients like glucose, anesthetic, water, alcohol, nicotine can all pass through this barrier. So nicotine, stimulant, alcohol, depressant, anesthetic there puts you to sleep, right? Knocks you out. So smaller molecules there can get through, but big ones there like proteins and all these, they can't, okay? It is the largest, most complex portion of the nervous system. That is the brain, containing 100 billion multipolar neurons. It's a lot. And as you get older, the number of neurons decreases. And you have to think there that children, like I got a 5-year-old and an 8-year-old, and at 7 o'clock in the morning, they're just up. And they're up like mad people, running around, doing this. They're doing 5 different things at once. And, you have to think that children there, they have their senses. Their sensory perception is firing 1,000,000 times more than mine is. They're absorbing, they hear things that we don't see. We see things, they acknowledge things. They're just like lightning rods, okay, as far as information vectors. But the number of neurons there decreases in our brain as we get older. All right, getting older. We can divide the brain into a number of areas there. There's it's called the cerebrum. This is the largest. Okay. Involved in higher mental function, we have the diencephalon, which is close to the brainstem, processes sensory information. We'll go into more detail into all of these. You got the cerebellum there at the back, which is involved in motor coordination, muscular activity. Brainstem there coordinates and regulates visceral activities, organ activities. Viscera means organs. Okay, we'll go into some more detail for sure. The meninges here, and again, you just look at how much information is in here, and all I'm looking for, this slide here is dealing with these guys here, so that's all I'm looking for there. So if I'm going to go after anything as far as a test goes, it's right here. Okay, but on a testing situation, you really don't have to memorize these things. You just got to be able to find them. Hopefully there, you've studied enough there that you will be able to recall them. And but even doctors, when you walk into a doctor's office, you'll see in the background there, you'll see a bookcase there with 50 textbooks. Doctors don't even know it all. You can't have it all in here. So being able to recall where it is, these kinds of things, is all. This is great. The brain and the spinal cord are surrounded by membranes. They're called meninges, and they lie between the bone and the soft tissue. And you'll see here, I'll try and blow this up a little bit. There we go. And not really going into the brain just yet, but you'll see there, these meninges, they come all the way down. And you'll see here, this is just the top part of the brain. Okay, so we've just kind of blown up this area here. There's the skull of the bone, or the bone of the skull. Okay, and where you see these linings here? Okay, these are the meninges here. So you'll see your dura mater, and it's this in here. See that white area right in there? Okay. You have your arachnoid mater, which is that line right there, that pink line right in there. Okay, and both of these two here, both of them really they don't touch the brain itself. They're kind of off the brain. Okay, your pia mater, this one here, is in contact with the brain. Okay, and you'll see there that see the space in here. It's just the space in between the pia mater and the arachnoid. They call this there the subarachnoid space. Okay, there's that space there. So, and again, can I go into more detail? Yeah. Will I? A little bit. Okay, but that's what we're looking for there. The meninges there, the dura mater, is the outermost meninge. Okay, is made of tough, white, dense connective tissue. Okay, contains many blood vessels. So the dura mater has blood vessels. That's that white space in there. Okay. The arachnoid mater, middle meninge, thin, no blood vessels. And neither of these there follow the convolutions of the brain. Okay, so they're kind of off in their own thing. Dura mater, blood vessels. Arachnoid, nada. Okay. The pia mater, which is the pink line right in here, that meninge right there, this is the innermost. Okay, very thin, contains some blood vessels and nerves, and is attached and follows the contour surface of the brain as well as the spinal cord down below. Okay, you'll see it goes all the way down into there. Okay, and that's all I'm looking for there. Am I going to go into any more detail? I could, but I'm not. We have so much to cover that's all I'm looking for there for those meninges. Okay. The CSF, cerebral spinal fluid. Okay. Protection. The spinal fluid there protects the brain from damage as a buffer or a cushion, right? It's through buoyancy. It goes right back to that tomato, that whole scenario, okay? Because the brain is immersed in fluid, its weight is reduced from about 1.4 kilograms to about 50 grams. It's the same reason a hippo lives 80% of its life in water. Okay, it's got these wee little legs and big body. It's not really good for running around, but yeah, hippos can run. One's running at you, you better move it. But it's the same thing. Okay, it's all about buoyancy, keeping that brain safe. Excretion of waste products there, the one-way flow from the CSF to the blood. One-way flow from the CSF to the blood takes potentially harmful metabolites, drugs, and other substances away from the brain. So there's a one-way flow through the CSF back to the blood. Okay? Not a two-way. The endocrine medium there for the brain, the cerebrospinal fluid serves to transport hormones there to remote sites of the brain where they may interact. Endocrine system, I love it. We hit that there, I think, the last 2 weeks. So I'm going to kind of stay away from hormones as much as possible until the last 2 weeks there. But there's 2 ways there that the brain talks to my big toe. One is nervous system, which is very fast, very strong, very short-lived. The other way the brain talks to my big toe is through the endocrine system, hormones. Now, this tends to be a slower system, but the effects can be enormous. Okay? Even you look at, childbirth there, one of the hormones there, oxytocin, which we can actually synthesize, make. And if a mom is in labor or is not in labor but should be, we can inject oxytocin in, and mama will start contractions. Okay, so there's we'll get there. We'll get there. Am I going to go endocrine on this test? No. Okay. As far as I know, I don't think so. We haven't really covered hormones in any capacity at all, so you don't need to worry about that. But I would know buoyancy for sure. I got this one, and these are right. A lot of these slides are right from your text. I think the textbook is awesome, and there's lots of good stuff there. So this is A, this is B, and this is C. And all these are is just showing you there where fluid in the brain is. Cerebrospinal fluid produced by filtration of the blood, okay, by the choroid plexus. We'll get into what a plexus is, okay. It's just kind of a mixture of nerves coming together. Of each of the ventricular flows inferiorly through the lateral ventricles, okay. So you'll just see there, I'm not really interested in any of these. I'm just interested there just to show you there that there's lots of fluid going on. You'll see there the arachnoid villus there where the CSF is reabsorbed into the blood. Simplified diagram showing flow of the CSF. And you see there it's a one-way flow. And have a look at the book there. It's really, really good. Okay, so our brains are encompassed there by this fluid there that protects it, keeps it buoyant, and creates this barrier. Just some more here. Okay, and these are just, you'll see there highlighted in blue. Okay, and you'll see that there's lots of fluid in there, and that's what we want. That's a good sign of a healthy brain. 6 major... Oh, my goodness, it's getting louder. Can't believe it. Just not my day. The 6 major parts of the brain, and I was going to put them somewhere, and I just didn't know where to put them, and I just left this here. Okay? Oh, I hear you. There's like 20 people outside my window. But you'll see here, it's crazy. This is where we're going to be talking about. This is going to take up probably about half. We're going to talk about the cerebrum, the diencephalon, the midbrain, the pons, the cerebellum, the medulla oblongata, and we'll down into the spinal cord. And I'll zoom out here just to show you guys what's happening. Okay, but this is your little table here that we're going to go through. So let's just go through these. So this is my cerebrum, my cerebral cortex. And you can see, by far, it's the biggest. Okay, and what does it do? It does lots. Okay, we'll get there. The diencephalon, okay, right in there. We got the midbrain, which is in here. Okay, we have the pons, the cerebellum, the medulla oblongata. I just love that word for some reason. I don't know. And spinal cord down below. And here's a shot there. Oop. Okay, of a real brain there cut in half. And you'll see there's your brain stem. Okay, and you'll see that it's from here to here. So this is what they call the brain stem, which continues on there into the spinal cord. Okay, there's your midbrain, your pons, and your medulla. Okay, and you can see there, you're just looking at this going, I don't see any difference. That's exactly what it is, but there they are. Okay, we'll get into more detail. Okay, there's the pineal gland. Okay, your cerebral cortex up in here. Yeah, we even talk about the hypothalamus and the thalamus as well. And you'll see there that there's a bit of a hole in here. There's a hole in my brain, and we'll get there. Okay. The structures of the cerebellum. Okay. The largest portion of the mature brain has two cerebral hemispheres. I like that. There's a deep ridge of nerve fiber there, the corpus callosum. Okay. That connects the hemispheres. But the 5 parts of the cerebrum there that I want you guys to be able to recall. You've got the frontal lobe. You have the parietal lobe or parietal lobe. However you want to say it. It's not an English test. Okay. We have the temporal lobe. The occipital lobe. Okay. Then we have the insula. And you can't see it. You got to take the brain and cut it in half. And you'll see here that in the middle, okay, is this insula. And they all have their different functions here. We're going to go into them. And again, we're not going heavy. We're just like taking a flat rock against flat water. Okay. The cerebrum there is involved in higher brain function. Okay. Such as, and you think about this, I don't know, it just blows my mind, just the entire ability to, through our eyes, we can create chemical impulses there that travel to our brain, which therefore our brain will store this image chemically as a memory. And, you know, you have short-term memory, and if you use that short-term memory long enough there, it gets jettisoned there into a long-term memory. And it's still so much fun. And it's such an amazing thing there, the brain. It's involved in interpretation of sensory input, initiating voluntary muscular movement, memory, integrating information as far as reasoning goes. You know, the whole idea of critical thinking, reasoning, why is something like this? That's all involved in with the cerebrum there. Okay. To move along there with the cerebral cortex here, the whole idea of gray and white matter, we touched on it there. I think it was 2 weeks ago. We kind of looked at it there a little bit. The cerebral cortex there is covered by these ridges, okay, gyri or gyrus, okay. This is gray matter, okay. These shallow grooves that separate the ridges, you'll see there, they're called sulcus or sulci. These are the shallow grooves, okay. The deeper grooves, like this one right here, we call this there a fissure, okay. And beneath the cortex lies a mass of white matter there made of myelin nerve fibers, okay. And you'll see there that there is my white matter in here, okay. And I'm just going to put that right there. So this white matter here, and when you think of white matter, you think of Schwann cells, you think of myelated sheaths, right? And that's what we're talking about there. So a little bit, your book I think actually has better pictures, okay, of this, but it's exactly the same thing. Okay, so have a look at that, and away we go. Thank you. Here's a nice one. Isn't that a good looking brain? Look at that nice pinkish hue. Boy, that one there, IQ of about 145, I think. There you go. The also called the this is the frontal lobe, also called the executive. This is like the big boss, right? Involved in behavior, personality, motor control, primary motor area, frontal eye field, even speech. And I put this in here, Broca's area. Am I going to ask you about Broca's area? No. But do I encourage you to go on and do some research and reinvent our entire thinking of the Broca's area? Please do. And when you do, shoot me an email. I love it. The just some of the functions there of the other parts there of the cerebrum there, the parietal lobe, okay, the somatosensory area. Somatosensory. Somato means body. Sensory, so body sensing area. Okay, you have your temporal lobe here. Auditory, hearing, olfactory, nose, smelling. You have your occipital, which is your visual cortex. And you see your eyes, zoom, right there, straight ahead. The insula, that's this one here. It's hidden in the lateral fissure. So the only way you can see it is if you go digging for it. It's involved in taste, smell, organ control, body balance, emotional and perceptional info, desires and cravings. That's what we're looking for there. And you could see there might be a multiple choice question 1 or 2 there. Is it anything crazy? No. Okay. A little bit there about your test. It'll just be multiple. The majority of it'll be multiple choice questions on a specific topic. And then there will be some anatomy diagrams that you'll have to fill in. Like I can't give it to you, but something like this that there you might have to label. Did I just say that? There you go. Moving on. I don't even know what kind of time we have here. Oh yeah, we're almost another 5 minutes there, and we'll take a 10-minute break. Okay? And because this stuff is, I can't beat you with this stuff for 2 hours straight and expect you guys to utilize it properly. So another 5 minutes there, and we'll take a 10-minute break. The diencephalon. Okay, we're moving down now. We're kind of into you see where we're at. There's your spinal cord. So we're kind of into, just trying to find a better slide here. Yeah, we're down into this in this area here. Okay, and yes, we're into this area in here. And that's what we're going to be talking about there for the next couple minutes. Right there. So you see what's involved here. We've got the pons, okay, the pituitary gland, optic nerve, the thalamus, hypothalamus, the medulla, okay. So the diencephalon lies above the brainstem and contains the thalamus and the hypothalamus, okay. So right in here, this is what we're looking at right here, okay. This is just some the pituitary gland. When we get more into hormones there, I think that's what week 12 and week 13, we'll be hitting the pituitary gland like a dirty shirt. Okay? So, but we'll hold off on that one for now. Other than, we call it there the master gland, produces many hormones that travel throughout the body. Can you guys hear that? What are these guys doing? Thalamus. Focuses attention, detects and integrates sensory information. Okay. The hypothalamus, okay, sexual reflexes, body temperature. Oh, the hypothalamus. I'm sure you guys have actually, you guys know something about the thalamus, and especially the hypothalamus. Body temperature regulation, water, carbohydrates, fat metabolism, optic nerve connection. You know what I mean? There's just even regulates the pituitary. And when you get to the pituitary, there's the anterior pituitary, which secretes some hormones. There is the posterior pituitary, which actually is an extension, okay, the hypothalamus, and it produces its own. Sorry, you don't hear that noise? Can you hear me? Oh yeah. Oh, okay. All right. Hey, if you guys don't hear the noise, then that's great. I'm hearing it, and it's irritating me. Those guys there, why can't they do that another day? But I'm glad. If you guys can hear, that's all that matters. And if you guys are happy, I'm happy. The moving on there to the diencephalon, there is a very, 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 very interesting system that I'm just intrigued by. And it's called the limbic system. And how do I explain this in a couple of minutes there before y'all can take a break? I want to ask you guys a question. In the past 48 hours, or even this past week, how many white cars have you seen? And you're probably thinking, okay, man, what's this weirdo talking about? Why? What do you mean white cars? Why am I looking for white cars? I don't know how many white cars I've been. What kind of a silly question is that, Ian? And you're right. It is a silly question. Now, if you were in the market, if you are looking for a car, and you're looking for specifically a white car, and now you just go off and start living your day. You're going to school, and then you go to Zehrs and get some food, and then, you take a walk downtown to the beach. I bet you'll start to see more white cars. Why? Because it's in here. It's your limbic system, and it's your filtering system, and it is wicked. The whole idea that what we see, what I'm looking at right now, living my life, I have the ability to alter what I see. I have the ability to alter what is allowed or enters into my eyes and my ears so it goes to my brain. I can alter that, which is a lot of people, they really don't know this, that you can alter your filtering system. You can augment it. You can change it. You can extrapolate it, or you can condense it. Maybe you're having a bad week and you know what I mean, you're just not interested in anything. So your limbic system is basically just going to shut down because you're not looking for anything. But if you are looking for something specific, you're looking for, I don't know, a new TV show or new, you know what I mean? It's something there that you want. Your filtering system will adjust to start looking for that almost unconsciously. So as far as even doing your homework, you can augment how you learn because you can augment how you perceive things, life, and how you interact with life. And really, really, really cool. The limbic system in the area of the diencephalon controls emotional experience and expression. By generating pleasant or unpleasant feelings about experiences, the limbic system guides behavior and may enhance the chance of survival. I'm just going to play this one little movie here, and then y'all can take 10.
How to escape the heat if you don't have an air conditioner.
Oh, I don't know how to escape the heat. All right, there we go.
Welcome to 2 Minute Neuroscience, where I simplistically explain neuroscience topics in 2 minutes or less. In this installment, I will discuss the limbic system. The word limbic comes from the Latin limbus, which means border, and the limbic system was given this name because its structures lie along a horseshoe-shaped area of cortex It appears to be a border between the cerebral cortex and the subcortical structures of the diencephalon. There are many processes associated with the limbic system, but the system is most frequently linked to emotion. There is no consensus on the structures that are considered a part of the limbic system, and some argue that it is too much of a simplification to consider something as complex as emotion to be handled by one group of brain structures. Regardless, these are some structures that are often included in the limbic system. The amygdala is an almond-shaped collection of nuclei found in the temporal lobe that seems to be especially involved with fearful and anxious emotions. The hippocampus is next to and interconnected with the amygdala. Although it is considered part of the limbic system, the hippocampus is generally associated with memory more so than emotion. The parahippocampal gyrus is an area of cortex that surrounds the hippocampus and also plays a role in memory. The cingulate cortex or cingulate gyrus is found just above the corpus callosum and is involved in various aspects of emotion and memory. The septal nuclei have connections with a number of other limbic structures and are thought to be especially important to pleasure, reward, and reinforcement. The mammillary bodies are two groups of nuclei that are involved in memory and have extensive connections with the amygdala and hippocampus. The fornix is a fiber bundle that carries information from the hippocampus to the mammillary bodies and then onto the thalamus. The hypothalamus controls hormone release via the anterior pituitary and can exert widespread influence over bodily states to maintain homeostasis.
Now, just to be, I'm not going into all of these. I just wanted there to give you guys a generalized, I'm not going to test you on septal nuclei, parahippocampal gyrus. No, I'm not going into that. I just wanted to show you there that I have other videos there with this one. That's just to give you a bit of roundedness of where we're at. That this system here is very extensive and it relies on the cerebral cortex and where it borders there with the diencephalon. And you'll see there that there is something going on. I just wanted to show you where it is. Let's take a 10-minute break. I'm going to stop recording, and we'll see you guys back here at 1:05. I've got 12:54. We'll see you guys back here in 11 minutes. Okay, so I'm going to stop recording, and we'll see you guys back. I'm not going to shut down the WebEx window. I will leave that open, but I'll leave it on mute. Okay, we good? We'll see you guys in 10. Thank you. I'm just trying to figure out how to open this now. Why won't it open? Anyway, let's stop this.